physically by this hardware NIC card, and it is getting sent over this physical cable back to this particular machine. Okay, so he is getting received. So all this, like what, physical related activities which is being performed, means your informations getting sent physically from here to here. This is the physical layer job. Okay, data link layer basically provides all these informations like MAC addressing informations. Okay, and it also performs error checking. Error checking means this particular value, everyone. Okay. This is what we call CRC, stands for cyclic redundancy check. Okay, this redundancy check. Okay, this is a value CRC. This CRC stands for cyclic redundancy check. It is basically a mechanism by which, like what, data link layer, okay, of the system can identify that if any frames, what exactly this machine is sending to this machine, if any frames contains any type of errors or not. Okay, if it contains an errors, then it will send it to the transport layer for error correction purposes. Okay, because at the transport layer error correction is being done. Okay, at the data link layer error checking is done, at the transport layer error correction is done. So data link layer and transport layer, always it is always there in touch with each other regarding error checking and error correction. Okay, if any frame contain any type of errors, always data link layer informs the transport layer, and transport layer basically performs the retransmission, and this is the way error correction is done. Okay, so how exactly they can find out that if any packet contains any errors? Basically you have a CRC value in a packet. Always we get CRC value. This value is calculated based on an algorithm, and that algorithm is called FCS algorithm. Okay. FCS stands for frame check sequence. Okay. Frame check sequence. This is the frame check sequence algorithm, which is basically used in order to calculate this particular value. Okay. Now this particular value, how exactly it is coming? So this packet is being sent. Let's imagine that this machine is sending this packet. So this value is calculated on this packet and it is getting sent over here. When this machine is receiving this packet, at the time it will calculate, it will run this algorithm and it will calculate this value. If this machine compares these two values and find it similar, then it will declared as error free. Okay, means it doesn't contain any errors. But if this value, if it differentiates from here, so let's say that it is 1 2 3 4 9 and this is 1 2 3 4 5, what this particular machine has sent, then it will be declared errors. Okay, means the packet contains errors. So what exactly this machine will do? This machine's data link layer, it will inform transport layer that we have got a packet which is not having the same value what we are getting. So it contains errors. What this machine will do, this machine's transport layer immediately communicate with this machine's transport layer and it will request for a retransmission of the same packet. So again, this particular packet gets retransmitted with a new value. So let's say that this time they're sending with this value. So each of these values are calculated, okay, based on algorithms. So this is the new packet again coming in. Okay, now once it receives it, it basically runs the same algorithm, and if it finds the same value, then it is declared error free. So this packet is getting processed from data link layer to network layer, then transport, session, presentation, and lastly, at the application layer, the informations, the contents of this packet is displayed in the browser or in any of these applications. This is what exactly is going on. This value, it should match over here, over here. Okay, and these are basically done using formulas, everyone. Okay, these are mathematics formulas are there, like advanced calculus. Okay, those type of formulas we are having in this type of algorithms. this algorithm is concept of data structure. Okay, it is a concept of data structure. We are not going into that discussion of data structure because that is totally different concept. Okay, and this is the algorithm name. What exactly you need to know. Okay, the main idea is this particular value, it should match with this particular value. Okay, because when it matches at the time only, it will be declared error free. Okay, this is how the communication is going on from top to bottom, bottom to top, everyone. When you send anything, this is how the information is getting processed, is getting sent by this type of cables. Your switch, this type of devices called switches. Okay, this type of devices is called a switch. It directly works at data link layer. This type of devices like bridge, this device, it is an example of data link layer. Directly they work at data link layer. Okay. Physical layer, you are having the cables, all this type of devices like hub devices, you are having hubs, this type of devices is a hub device. We're using it, okay, to connect our machines. This directly work at physical layer. Repeater device we are having, okay. The cables, we have different types of cables in network. This all this network interface card, NIC, okay. All these ports where exactly we are transferring data. Okay, all those transmission mediums what we are using to transfer the data from one machine to another machine. This is what exactly we're having. Okay, the communication, the intercommunication between source machine, between the sender PC or the receiver PC, or between source and destination machine. This is the model, 7-layered model. So I've given all the informations in that particular notes. Simply just go through all these things. You will understand very in a very easy format only it is given. Okay. All of you understood?
Yes, sir.
Yes.
Yes, yes, yes.
Sir, sir, a
Ah.
question, a doubt, sir.
Bolo.
Sir, sender can be of number of any means there can be any number, sir. Means
Sender can, yes, on internet,
receiver.
on internet, so there are so many number of senders. Any machine which sends request, right? Any machine which is sending information, that is the sender. Any machine which receives, any machine can act as a sender and receiver. Okay. Ultimately, every single machine is a sender and a receiver. Every single machine. Okay. Let's talk about your laptop. Let's say that this is your desktop. Okay. And this is Google server. Let's say that this is Google server and this is your desktop. When you access Google server, you send information, right? Yes or no?
Yes, sir.
Yes,
From
sir.
your
Yes,
machine, when you access Google server, you send information. So you are the sender. But once
Yes.
Google server is replying back to you, then you receive, right? Information.
Yes, sir. Yes, sir.
So
Yes,
every
sir.
single machine is working as a sender and receiver. Okay. It is not
Yeah.
like that only one machine can be a sender, only one machine is receiver. It is not like that. Every machine, to do data exchange, to make communication, always sending and receiving, you have to do. If you are simply just doing only sending and you are not receiving, then you cannot make communication. No?
Yes,
So one
sir.
This
question
is,
is this.
Yeah, got it, sir. Got it.
tell me, Amit, go on.
Sir, actually in TCP three-way handshake process, the synchronizing packet which we are sending,
Hmm.
the synchronized packet, so that one is the data that we want to share as to a receiver.
No. It is not the data packet.
Mhm.
It is the connection. It is TCP packet.
Okay, connection.
For establishing the connection.
Okay,
Okay, once the connection is established, after that only the actual data packet will be sent to the receiver.
okay. Oh, acha, acha.
Sir,
Okay.
TCP and UDP are particularly used for modem or routers, kya? Or is it used from
No, not
content?
for modems or routers. For this type of services, it is used. Okay, like you have seen the port numbers, na? These are port numbers. This 0 to 1023 port numbers, these are the services which is offered. Like for HTTP, that is your web service. FTP for file sharing service. This is for DNS, domain name service, telnet service, remote access, mail deleter services. All these services are being accessed using TCP UDP port numbers. Because on a port, a certain port number, only you establish connection in a machine. Okay, at the layer 4 level. That is why exactly these port numbers, 1024 port numbers are reserved for services. Okay, reserved for protocols or services. That is correct. Okay, so all these port numbers always you are using on a daily basis. Remember, you are building connection. In order to connect to this services, okay, all the services on this machine, you need to use a port number, because these services are running on a certain port number in this machine.
So
Getting the
basically,
point?
we are using, sir, IP address, sir. So how does, sir,
IP address you are using just to identify a system. Just to identify a system. Let's say that you are having lots of systems over here. You have lots of systems. How do you identify all the systems? Using their names, no? PC0, PC1, PC2, like that. You are identifying, right?
Yes.
Yes or no? This identification is done using IP addresses. But what is running within this PC0, what services are running within this PC0, PC1, how come you can identify those things? Using TCP, UDP port numbers. These are all services, no? All these are services. These services you can identify using port numbers. So if you want to access like email service like SMTP, then you will send from here to this particular machine email service port number, which is 25, right? SMTP, yes or no? SMTP port number 25. Let's say that you want to visit a web page. So this web service is running on this server. So you will be sending from your machine to which port number? You will make connection on this machine. Port number 80. Port number 80. HTTP is 80, na?
Yes, sir.
These are logical port numbers, not physical. Remember this. These things, these are logically it is happening. Okay. Inside the system it is happening. You are not seeing it. These port numbers are there for building the connection. Okay. To which particular services you want to connect. Because all these machines, they're providing all these services in the internet. But which service you want from all this? For example, you go to a restaurant, right? Like what, these days we are not having that much frequency in the restaurant, but earlier, before the corona pandemic, we used to go to restaurant, right? Over there, we basically used to get the menu, correct?
Yeah.
Yes. So in the menu, you basically see all those, like what, names and all these things, recipes are there, right?
Sir, items.
All this, like what, different fast foods, okay, starters, all these things you are seeing. But you get to choose, right? Which one you want, or you choose all of them. Are you telling them that bring all the things what you are having in your restaurant?
No, no, sir.
Huh?
No, sir. No, sir.
You are choosing the things what you want, right?
Okay.
So if they are providing you 50 items, okay, 50 recipes, then you are simply just choosing whatever you want. 2, 3, 4, 5, like that. You are simply just choosing. This is what exactly you want. You are specifying it from this list of services by using port numbers. Okay, so if the system wants only SMTP port numbers to request for it from this machine. If he wants DNS, then he is using DNS. port number to request informations from the system. Simply just like that. These are all services which is running on internet servers, and you are just requesting using this
So we
port
have to learn
numbers.
it all by
Understood?
heart. Yeah, this all for TCP and UDP numbers.
By heart.
No, common TCP UDP port numbers I have given you, right?
Yeah.
Yesterday.
Yeah.
This is what exactly you have to remember. Common at least 20 to 25 port numbers. If you remember, that will be good. See, I cannot say that this 20 and 25 port numbers only you have to remember. Okay, I cannot say this because in networking, always the more you know, it is your advantage only. Okay, it is your advantage only. If you want, you can remember more port numbers. Okay, like 40, 50. It is totally up to your capacity, how many port numbers you can remember. But this thing you can do it. Okay, I leave it to you how many port numbers you want. Minimum, make sure that 20, okay, 15, 20 port numbers at least you have to remember.
Any
Understood.
trick for this? Remembering?
Renuka is asking
Any trick?
Yes.
any trick. Now see what type of question I'm getting. Any trick is there? No, like what trick? What type of trick you were asking,
Remembering
Renuka?
this port number.
Okay,
हाँ,
no, there is no trick for this.
okay. ठीक है sir.
There is no trick. No shortcut is there. Now the thing is, how many of you believe in shortcut?
Sir, it's better to go in the process, sir, rather than a shortcut.
Okay, okay, good to know. But what about others? What others think? Is it good to take a shortcut?
No, sir.
Hello,
No, sir. No,
Damini,
sir.
Amit,
No sir.
what all of you guys
No,
think? In life,
The shortcuts are always shorts. It won't be
Long
relied forever. Yeah. So make it, let it be, if it's a long, but it will be helpful for long time.
yes,
Sir,
yes.
the more we know, the more we can get, sir.
Hmm. So always remember this, what you have told. Okay.
Yes, sir.
It should not be like that today you are saying and tomorrow you are looking for shortcut itself. Rupesh,
Sir,
No, sir.
sir, I did not.
because sometimes it happens, right? Sometimes it
Yes,
happens.
sir.
We all,
Sometimes
after all, humans, right?
we
Our mind.
need to choose
See.
shortcuts sometimes.
See,
Not all
it
the
is
time.
it is not your fault. I'm not simply just saying that it is you who is looking for shortcut. Like Renuka has asked for it. Okay, basically
Yes, sir.
I understood her intention regarding that, but it is like what it, since we are humans, our mind always looks for this type of things. Always it thinks
Yes.
like that. Okay, so it is
Yes,
not your fault. Okay, you should play your mind in the way you want it to play. Okay, means
Yes.
you should be operating your mind.
Yes.
Your mind should not operate you. Make sure that you remember this. Your mind always will tell you
Yes.
that, okay, you have to finish this fast. All these things you have to do it very fast. Okay, this is what exactly your mind always tells you. But you should be instructing your mind that this is the way I should be going for. Okay, so controlling mind is the most important thing in these things. Okay, because see, the thing is, you have joined this job internship. Okay, now the next thing is how quickly I can finish it, how soon I can get a job, how soon I can learn all these things. This is real, everyone. It is real time thoughts which comes into our mind whenever we take admission in something, whenever we join job. How do I get a promotion? How do I get maximum salary? Okay, all these things, all this type of thinking, it comes in. Okay, it is your mind who is telling you all these things. Okay, who's doing all these things with you. So make sure that you control your mind, okay, in such a manner so that like what your mind obeys what you are telling it. Okay, it is not like that your mind is operating you, okay, in the wrong direction. It should not be like that. Okay, because whenever you find that this is a little bit complicated, okay, you are finding it a little bit difficult, immediately your mind is diverting from that. Okay, and it is basically looking for ways like what shortcuts and all these things. So don't basically fall in traps. Okay, this is the traps. Shortcut is always for traps. Short-term goal you can achieve it, but in the long run you will be having issues. So make sure that you remember all this.
Yes, sir.
Okay, sir.
Okay, everyone. So now we are move.
Sir, can you NIC card?
Mm.
Can you explain that NIC card?
Network interface card is basically this type of port you are getting. Okay, this type
Yes, sir.
of ports you get.
Sir,
This,
it
can you see
contains
this interface?
MAC address.
Can you
NIC
see this
card contains.
interface?
Yes, sir.
This is the port on system. Can you see the MAC address over here?
Yes, sir.
Yes, sir.
This is the MAC address which is found on this port, and this port is provided by your NIC card.
Sir, in sender and receiver, sender and MAC address, different MAC address and receiver side also different.
Different MAC address, good. Yes, because
Sir,
MAC address
sir,
it should be different.
No.
Sir, I'm having a small doubt, sir.
Yes, who is
Uh,
asking?
Sir, Rupesh.
Rupesh, tell me.
Sir, how can we understand that in an IP address that it's kind of very big number, no, sir?
Yes,
it's kind
no,
of
no, no.
very-
It is not a big number. See, the thing is, there are some ranges are there which you need to remember. Okay, this is a subject of memorization. You have to remember certain ranges. Based on that range only, you have to configure your IP address on your system. Okay.
Okay, sir. It's a new thing which I've learned today, sir.
IP address, it is basically a decimal number. Okay, you will understand that when we discuss about it. Most probably in the next session you will get to know about IP address. So
Okay.
we'll discuss all these things in a detailed manner. Okay,
Okay, sir.
but this particular thing we are having the network devices, everyone. Okay,
Yes,
so
sir.
this is your network devices, everyone. As you can see that we are having all these devices within this yellow circle. This particular circle simply just representing a network, local area network. And like any network, all these devices, always you will find it. Okay, most of the time you will find laptops, desktops, servers, routers, switches, tablets. Okay, this type of devices, IP phones, you can find it sometimes. But all these type of devices always is being used in network. Okay, hub, bridge, these two devices are old. Okay, a little bit old devices. We are not basically using it these days. Okay, why we are not using it, you will understand it. But hub, bridge, these devices are very old type of network devices. Mostly used devices these days are these switches, routers, servers, PCs, laptops, tablets. Okay, these are the mostly used devices in a network. In any company you go, always you will see that they are working with these devices. Okay, so what devices we are going to be discussing? This is over here. Okay, first of all we'll be discussing about hub, then switch, router, bridge, repeater, modem, all these things. Okay, so starting with the hub device, everyone, we are having this particular network diagram available. As you can see, all these 4 laptops are getting connected to this particular device. This is a centralized device called hub, and this device is allowing connectivity, means allowing communication from any machine to any machine. Okay, this is the source machine, this is the destination machine. From here, if I want to send anything to this machine, this is when my packet goes to the hub, and what hub is doing, it is simply just doing broadcast. Broadcast means one-to-all communication. Means from this machine, it will receive it and it will broadcast it to every single machine which is connected to it. So this packet originally was sent by the source machine. Okay, and it should be going to the destination machine. But this hub is doing what? It is broadcasting it to all these other machines, in which it is connected. This type of behavior always is there in hub, and which is considered as a security risk, because anytime we can have any type of hacker machine in our network. Like in internet, we have lots of hackers are out there who steals informations. Like when you send any information like this, and if this information is very much crucial, let's say that you are sending a file to this machine, this file is getting also to a hacker machine, which is not good. Okay, the hacker machine right now get to know what exactly we're sending to this machine. This type of broadcast by this device called hub, always it happens when you anyone sends anything to hub, it is getting broadcasted to all these other machines. Okay, and this is considered as a security risk, because what we want is we want to communicate directly to this machine. No broadcast should happen. Okay, one-to-one communication always is called unicast communication. Everyone, means this machine is communicating directly with this machine. This type of communication is called unicast. And when you send information, you send one packet and it gets delivered to all these other machines by this type of device, it is called broadcast. That is called one. One means source is one, destination is all. One-to-all communication. And one-to-one communication is unicast. Okay, one-to-one direct communication is called unicast. This type of device called hub, this only supports broadcast communication, everyone. That is why anytime any machine is sending anything to this machine, every other machine is getting it. Okay, so when this machine is sending something to this machine, all these three machines are getting this packet information. Okay, so what he has sent, everyone will come to know. That is why we are not using it in the company. Okay, you will not find a hub device in any organization. The benefit is it is super cheap, means 800 rupees you can get a hub very easily. Okay, you can purchase this device like what, even 500 rupees also it is available, even 1000 rupees also it is available. Okay, these are considered as a super cheap device to set up a network. Okay, if you have couple of systems at home, you can simply purchase this device. It's called a hub device, and you can see all these ports. Can you see these ports, everyone? All these are ports to connect your
Yes.
laptop or desktop machines via cables. You can connect all these machines to these ports, and everyone can communicate. The thing is, whenever any machine will be sending anything, it will be broadcasted to all other machines. Okay, this is the disadvantage, because we want our information to be delivered to this destination machine only. We don't want it to be delivered to other machine, but this device will allow that thing to happen. Okay, it will broadcast everything. Whatever information is receiving, simply just broadcast. That's it. That is why we are not preferring this. We call it a dumb device because of this reason. Because whatever it is receiving, every single thing is getting broadcasted. Even the things which we don't want to broadcast, it is broadcasting it. This is what exactly is a problem. Okay, in the company, we don't want this type of communication. That is why we don't use it in organization. At home, if you want to set up, you can set up. You can purchase this device and you can basically set up. The device what we are using, this is your switch device, everyone. Okay, this is the switch device. This is considered as an intelligent device. Why intelligent? Because it performs unicast forwarding of frames. Unicast forwarding means one-to-one, direct communication. So here also we are having the same scenario where we have a hacker PC, we have a sender machine, we have a receiver machine. Okay, this is your destination machine. All these machines, they have a MAC address because they are connected via port. These are physical ports, and this is your NIC port via which they are connected. to this switch. Every single NIC port, they have a MAC address. This is the MAC address in which it is written. This is in hexadecimal format. We are having the MAC address of this machines, everyone. Okay. So every single time when a sender machine sends something, okay, to the switch, always the switch, it understands these informations very carefully. Okay, it analyzes these informations in order to find out that to which machine he has to deliver this frame. So if this machine is sending this frame, then to which, this machine or this machine, to whom he has to deliver the frame. This is found in the destination MAC. Can you see the destination MAC address over here? 1BAA is mentioned, which is this machine's MAC address. Can you see?
Yes, sir. Yes, sir. Yes, sir.
So
Yes.
when this machine is sending, this machine is the source, right? Yes or no?
Yes, sir.
Yes,
This
sir.
machine is the source. And to whom this frame is getting sent? To this machine. So this is the destination, right? So when the switch sees this information, okay, in the destination MAC, what exactly it does, it contacts its MAC table. Okay. This is the table which basically contains port to MAC address mapping, everyone. This is what we call the CAM table as well. MAC table, media access control, or content addressable memory, CAM. Okay. This table is nothing, simply these port numbers and this MAC address. These mappings are there. Can you see FA0/1? Can you see this is the MAC address, right? This is the machine's MAC address. Can you see
Yes,
over
sir.
here?
Yes, sir.
Yes, sir.
Can you see FA0/2? This is the machine's MAC address, right? Can you see that?
Yes, sir.
Sure.
And similarly, FA0/3, can you see this MAC address over here?
Yes, sir.
This is this particular contents in the MAC table. We call it what? Port to MAC address mapping. This is port number. This is MAC address of machines. This is the mapping. Okay, what switch always it maintains inside its MAC table. Okay, so this particular MAC address, okay, and this port numbers always is found in the MAC table. Okay, so how this particular switch is performing unicast forwarding of frames, it is based on this information. When it sees the destination MAC address is 000D.BD99.1BAA, immediately it contacts this MAC table, and over here it finds the same MAC address mentioned and the port number attaches with it, right? So what exactly it is doing? It is using this port number and it is forwarding this frame in this direction or in this direction. FA0/2, right? This is the port. So over here it is going. Getting my point?
Yes, sir.
This is the port number. From here it is collected. The switch understands that this is the machine which is connected to this port number. So he is not using 0/3. Okay, he is always using 0/2 because this port is connected to this machine, which is there in the destination. Okay, so MAC address always it is considered as a permanent address. Everyone, we call it as a hardware address because it is directly found in the NIC, network interface card. Okay, the port where you connect this cable. Okay, this is your LAN port. We call it LAN port or internet port. Okay, the port on your laptop, desktop machine where you connect your internet. Okay, this is your NIC, network interface card, which basically provides you that port. So this particular port is having this address, MAC address, which is always written in hexadecimal, means 0 to 9 A to F, which is mix of letters, numbers, everything. It is base 16 number system. We are representing it. Base 16 means hexadecimal. This is your example of MAC address. And always this type of address is considered permanent because we cannot change this address permanently. Okay, whatever address we are getting on the NIC, the network interface card, always that address, it is permanent. Okay, so it is not temporary, permanent address. So how many bits address we have? MAC address. How many bits? 48 bits
48.
address. In which format we write it? Hexadecimal
Hexadecimal.
format. How many
Yes.
sections it is having?
It
Two
contains
sections. What are those sections? One is the
UI.
OUI,
UI
another is the device
device
ID. OUI stands for what? Organizationally
Organizationally unique
unique
identifier.
identifier. Now, used for what purpose? OUI?
Identify
You
the
can
vendor of
The
the
vendor
NIC.
of the vendor of the NIC. Vendor means what? Company. Okay. Companies like Cisco, Microsoft. Okay, these companies. Those companies who manufactures this NIC. Okay. So you are having Realme. Okay. This is the manufacturer, right? How many of you are having Realme phones?
Me.
Redmi.
Yes,
Redmi
sir.
you are having, right? Then Vivo,
Yes,
you are
sir.
having Samsung, you are having Asus, you are having OnePlus, you are having Apple. All these companies, they are basically manufacturing. They are manufacturers of this type of hardwares. So to identify which manufacturer network interface card is this, okay, you are having lots of manufacturers available in the market, okay, but which particular manufacturer basically manufactured this product or manufactured this NIC? This is what exactly you can identify using OUI. Okay. And device ID always is used to identify the device which is made by a manufacturer. Let's say that Cisco has made like thousands of NICs, but out of thousands of NICs, every single network interface card is having a unique identifier to identify itself. This is, just think of it like serial numbers. All of your mobile phones, they have a serial number, right?
Yes, sir.
Yes, sir.
Yes or no? Is any one of your like one mobile numbers like what serial numbers are same? It is not,
No.
right? It will be different. Every single device, electronic device, what we are using, every one of this, they are having a separate serial numbers. Okay,
Yes,
and
sir.
not two devices will be having the same serial number. This is, just think of it like this. Okay, if you have two smartphones, so this is your smartphone one, and this is your smartphone two. If you have two smartphones coming from the same company, okay, let's say that you are having OnePlus smartphone, okay. So these two smartphones from the same company is identified using two separate serial numbers, right? Yes or no?
Yes, sir.
Different serial numbers will be there. Even the same manufacturer has manufactured both the products. Their manufacturer means their products, it is all like what, by itself it is having their identification. Okay, they will be having it. So not all products are having the same serial numbers. This is just like the same thing. Device ID always is used to identify the device which is manufactured by that manufacturer. Okay, because when these manufacturers, they are manufacturing their products, they are manufacturing lakhs of products, okay, in a particular amount of time. How do you identify each and every product of Cisco and Asus? Okay, which is helping it. Okay, so this is the differentiation, everyone. This is how exactly this 48 bits MAC address is getting divided. This particular first 24 bits, we are having exactly half 24 bits OUI, and the last half 24 bits device ID. Okay, this is exactly half up to A1